All right. As we know, the EPMA service is going away in the 11.2 version of Hyperion Planning. So fortunately, we have still the download utility that will help us to simplify the integration of planning system with on an external system. So if you are an EPMA, you are using EPMA for the current integrations, I think that you will find this interesting, and also you will find that useful, hopefully. So let me talk a little bit about the University of Missouri system. It includes 4 universities located in Columbia, Kansas City, St. Louis, Rolla. All 4 universities have are about 70,000 enrolled students. It also includes the healthcare system. All the system, the university system administration, the 4 universities, the healthcare system includes more than 31,000 employees. The system includes also extension programs and research and technology parks. A little bit about me. I am the Hyperion EPM architect at the University of Missouri system. I hold a Bachelor in Engineering and a Master of Science in Computer Science. I have more than 25 years in the IT industry. It also includes 15 years working in the Hyperion EPM suite. I am mainly focused on the Hyperion planning and Essbase application designs development, also in the EPM integrations and EPMA process automation. My general areas of interest also are related with data analytics and artificial intelligence. All right, what I'm covering here today, I'm going to talk a little about what we have, what options we have for the Hyperion planning integration, and also what is the outline load utility and what is a good option for us. And later I will see how we are going to load data and metadata from relational sources, how we are going to export metadata from planning into relational sources, and how we are putting all of these elements together. And finally, some recommendations for you to succeed using the outline load utility for your integrations. So let's start with the first part. What we have as an options for integration with Hyperion with external systems. Actually, we have quite an options here. The first one is the EPMA, the Interface Performance Management Architect. That is the one is going away, but you don't have to worry about it because we have options. We were using this EPMA solution at the very beginning when the university adopted Hyperion Planning, but later we realized that outline load utility actually worked better than EPMA. So at the very early stages of the projects, we removed EPMA and start using the outline load utility. Another option is Oracle Data Integrator, ODI, but it requires an additional software, additional services, additional configuration, maintenance, support, and so forth. If we want to do a manual upload or download of data and metadata, then we have the SmartView Planning admin extension. That is a great tool. If you want to upload manually members, dimensions, and you want to download also some data and metadata, and it's good for prototyping and to create proof of concepts. Also, we have the FDMEE. I have seen a lot of deployments out there. However, again, you need to deploy an additional service. You need to create a lot of objects in order to create integrations, and it's an additional overhead for maintenance and support. Then we have the outline load utility. That is the focus of this conversation. And of course, we have, in terms of data, we can import and export data out of planning using the Essbase utility out of the box information that is packed with the EPM suite. All right, let's see what is the outline load utility and what is a good option for us. Well, this is the out-of-the-box functionality of the Oracle Hyperion Planning on-prem service. It allows the integration of Hyperion Planning with any external systems, be it tables or files. We can use it as a command line statement, or we can embed that within any scripting language. It allows to import and load dimensions, attributes, smart lists, numeric data, text data from relational databases, and also for any text file like the text or CSV file. It allows export metadata from Hyperion Planning applications to relational databases and also to text files. And additionally, it allows to export data to text files, but not to relational databases at this point. And it's also, the more important point is that it's available with Hyperion Planning license. So no extra license, no extra cost. It's actually out of the box functionality, as I mentioned at the very beginning. So what is a good option for us? As I mentioned, it allows us to integrate Hyperion Planning with external sources or external targets using relational databases or text files. It provides multiple functions, like it allows to build and update dimensions, build and update attribute dimension, export dimension and smart list, load planning utility hierarchies, update smart list, load numeric data, load text data, that is really important, and also export data. In this conversation, I'm not going to talk about importing and exporting metadata and data to text files, because I have seen a lot of information out there. There is a really good group of information in terms of blogs and presentations. So the focus of this conversation is entirely relational databases. All right, so let's see how we can upload or load data and metadata from relational sources using the load utility. Let's take an overall look at the process. We have source systems. We can have finance, HR, and any other kind of data coming from ERP systems or any external system that we can use, or you can use for your planning, budgeting, and forecasting processes inside Hyperion. So in general, the general rule is to extract the data in some way. You can use ETL tools. You can use any other kind of integration system. You can take that data and provide the metadata and data feeds in the format that we need in order to upload that into Hyperion Planning. So in that way, the idea is to have tables for dimensions, a smart list, attribute dimensions, and data. And then we will include processes to load dimensions, load attributes, load smart lists, load data into the Hyperion Planning applications. All right, what we are proposing here is to have a process that will include three main sections. The first section in your process will include parameters that are common for your entire processor or your entire set of processes in your system. Something like, for example, the path to the outline load utility, it never changes, at least with one particular deployment. Something like the user, you have a single user for all your automation processes, then that user will, as a candidate to be in a global configuration parameters, the password related to the user that is encrypted, and in a password file, you use the regular encryption tool in order to create this file with the encrypted password. Something like the catalog, the database catalog, or essentially the database name that you will use as a source of target. Then the URL pointing to that service, the database service, and the driver that you can use. So those parameters are global. So we suggest to have a kind of global section for your process. Also, we encourage you to create a functions library. So instead of using the command line or make a call to the command line utility over and over and over in all the scripts and everywhere, the idea is that you create a wrapper. Essentially, you define which processes you need. And something like, for example, load dimensions from table, load the dimension from file, load data from a file or table or file. You define those processes, and then you wrap the command line for the outline load utility using the proper parameters for each of these processes, and then you encapsulate that, generating these functions. And then you will have the general process statements. Each statement or each task make a reference to one of these functions. And within this function, you call or you associate a property files. A property files, we will see a little bit more in detail later, is essentially the mapping between the source, the target, that in this case is the planning application, and also from the planning application to target relational tables. Each property files make a reference, in this case, to a source table. So you have different source tables for dimensions, for attributes, for smart lists, and for data. All right. The line utility, as we know, includes a huge number of parameters. So at the first glance, it could be really hard to identify which parameters I need and which set of parameters correlate with each other in order to have the functionality or to get the functionality I need. Well, we can take all of these parameters actually and organize them in some kind of sections here. For example, for the global configuration, as I mentioned before, we need to use the ones that point to the source. In this case, the database, the service URL, and the driver. And it's common for any task you can define. Later, in the library, the idea is that you will use some parameters that are common for each of the particular tasks you are defining. In this case, for example, we need this parameter if we want to refresh the outline to Essbase. We need to define which property files we are using, which database we are using, the user, and also which logs file. So we can separate those and assign these to each task that we need. Also, for each particular task, like load a particular dimension, load particular data set, you will use some parameters that point exactly to the data source. In this case, for example, we are saying we have this query. We are pointing to this particular schema if we are talking about Oracle with this particular password. We are going to load this particular dimension and this mapping. So you don't have to worry about that. Actually, I am providing this matrix as a reference, but you don't have to go back and forth and try to memorize or trying to, take this table as a point of reference. It's just one way to indicate how we organize all of these parameters. Okay, let's go then with the components we need in order to create this automation, to create these elements in the easy way. So first of all, if we want to upload dimensions from a relational table, we need to define that table. So we can have the structure like the parent-child relationship, and we can include some other elements here like the alias, data storage. If you have more than one plan type in your planning application, then you can use all the information related to each plan type. You can include UDAs, you can include attribute dimensions. So the question is, what elements do I need to update or do we need to include in my dimension load in order to update my dimension? Well, one tip here is if you go to the planning GUI, the planning graphic user interface, and go to the manual export, import export functionality and export the dimension. You can take, in this case, for example, the entity dimension and export the entity dimension to a text file. Then you open that file and you will see all the parameters there, all the parameters that you can update within your dimension. And then you pick the ones you want to update and include here in the data source. Now that you have the data source defined, then it's time to go and define the mapping. So the mapping here is done within a property files. The property files has three main sections. The first one is the JDBC parameters. It points to the data source. So essentially it points to, it relates to the query you want to use to retrieve the data, the schema you are having access to where this table resides, and the password to access that schema. You type the password. The first time that you create these property files, you explicitly type your password. But when the outline load utility uses these property files for the first time, it actually encrypts the password and generates a string like this one. So you don't have to worry about having your password explicitly indicated in any text file in your system. All right, the next section, as we can see, we indicate this -O is essentially a parameter that will let you know if you want to keep the order in the way that you have the members in your data source, or you want to ignore that. So it depends what you need. So in this case, we are ignoring that. But here, the D parameter indicates the dimension, the explicit dimension we are uploading. And then the query. The nice feature here is that you are working with a standard SQL queries. So you have a regular select statement pointing to the table you are intended to load. You can use any functionality that is allowed with the standard SQL. So you can use joins, you can create, suppress any column you want to. You can create columns on the fly. You can join with other tables. You can use the where clause so you can filter your source. So that's great because it's explicit. You know what to load, so you know exactly what you are pointing to, and you have control on that. Now, the other nice part is that having everything mapped to the source, then you map the target. So you map the source elements to the target data elements inside planning. And you use this, the idea is that this is case sensitive in the planning side. So you need to use exactly the names that planning defines internally. Again, how do we know which names to use here, like alias, colon, space, default? Well, when you export, manually export using the GUI interface, you export a dimension into a text file, you will see what planning is using internally. So the idea is that you use exactly the same naming convention found there in order to map the data elements into the planning. Then you have the nice point here, the nice map. You have the source, the mapping object, and the target. Now let's see how we can load attributes. Very similar, actually. You have the table, you define the parent-child relationship, any additional information you want to upload into dimension. Attribute dimension. You can have a structure here. You have a hierarchy. It's possible to upload that there. And what happened in the mapping side? Very similar. So the already familiar JDBC parameters. Then you have the query. We are indicating with this DA parameter that we are updating an attribute dimension pointed or associated with this base dimension. We have the mapping of the source with the elements inside planning. So it's very similar, actually simpler than loading a regular dimension. For the smart list, all that changes a little is the source. So instead of the parent-child relationship here, we have a flat list where the first column indicates the name of the smart list that we are uploading. Then we include the operations. Operations are add entry, update entry, or remove entry. Then you have the entry ID. If you don't use this field, then planning will create a unique ID, a unique identifier for each entry for you, but then you lose control a little. Like, for example, here, I like to keep control on what I am pointing to, so I define this entry very similar to what I have as the member for the smart list. As we know, the smart list, the items in the smart list need to start with a character, so that's the reason this is here. And also you can have the entry description. The mapping, very similar already. So we have the JDBC parameters here. Then we have the query, the regular query. Something different here is that we use the H format. So with this one, it indicates that you keep the format exactly in the same way that you find in the source. And DS indicates that we are updating a smart list, and you have to use this name here. There is no other option. So the only option for this parameter is HSP underscore smart list, the query you want in order to upload this data, and also the mapping to the target. All right, so what we have now is to identify how to load data. Well, very similar to the previous data sources. However, this data source for data is a little bit different than the one we used to have when we use load rules in Essbase to load the tables, to load data from relational tables into Essbase cubes directly. In this case, we need to specify the cube associated with the plan type we are loading the data to. We need to indicate a load dimension. So it's like a pivot dimension that you use to upload your data. And then you have members that are called the driver members, where you have the other members that you associate the data you are loading to. And all the other dimensions in your cube go here in the POV. That is a single field, so you have to separate all the other members using commas. But you can create that in using SQL, regular SQL. You can join the fields in a single one using commas without any issues. One important part here is that we have numeric data and we have text data. In this period dimension, we create an additional member, here the comment member, and we tag that member in planning as a text field. So we can load directly text data there. Now, what happened in the mapping side? We have the point to the connection to the source. Then we have a regular query. Important point here is that we are indicating the load dimension. We are indicating the SDM parameter, more or less maps what we have in the structure of the table. So we have the load dimension, we have the driver members, and we have the cube that we are uploading the data to. Regular SQL statement. I include the where clause here. So for example, you can see that we are uploading data related to our actual current for FY20. Then we have the mapping to the target elements inside planning using keeping all the structure that planning uses internally. And what happened with the data that is a text data, that is text data? When something like that happened and planning found the outline load utility finds that we are using a text field here, then it takes that information and includes that in the HSP text cell value table inside the planning repository. And then it assigns a unique identifier. This unique identifier that is an integer number, it goes and is stored under this member in the Essbase queue. So that's the way that we upload text data, and it's nicely done, and it is possible to do that in a single data load, including numeric and text data. All right, so now that we have the sources, we have the mapping, let's see how we can use all of these elements. So the suggestion here is that instead of use the call to the command line utility over and over with a big number of parameters, that you have to identify, okay, what parameters I need to use for this particular task, is that you predefine those tasks. So the idea is that you create a library when you define your task like load dimension from table, as I mentioned before, and then you define which parameters I need for that task. Here, for example, for this task, we identified that we only need 2 parameters, like the planning application we are working on, the property files, and an optional parameter that indicates if we need to refresh the outline or not after the data load is completed. Internally, you can define some other elements that we need, like the log file, exception files. Here I am, for the sake of simplicity, I am using some fixed names, but actually internally we are using the same name coming from the property files. We replace the extension and we use that as a log name, so you can have more control on what you are generating. Now, here is when we use the call to the outline load utility. So we define the parameters that we need for this particular task. The planning application is being used here, and the property file is being used here. And all the other parameters, the information for all the other parameters are coming from the global configuration file. So you don't have to define that over and over, and you don't have to worry about the changing those parameters everywhere whenever something changes. You can have a very fancy functionality inside your function, like sending emails, verifying if there are errors and send emails accordingly, create a fancy logs file and things like that, but it's up to you. Once you have this function created, you have options like load dimensions, load attribute dimension, and load smart list by using the same function. What changes or what changes the behavior? Essentially the property files that you are pointing to. All right, in the same way, you can create load data from table. A very similar concept. So you define the parameters or identify the parameters that are needed to load data from table, and the behavior indicating which type of data I'm loading and what is the source is coming in the property files. But it's very similar idea. So you can, with this function, you can load numeric data, you can load text data, and so forth. All right, so far, we have the definition of the components that we need in order to upload data and metadata. We define the sources, we define the mapping using property files, and we define the wrappers, that is the functions that we need to use those parameters. Now let's see how the export process works. So actually, this is simpler than the import process. We start with the planning applications. Then we use the data export process with the outline load utility to export dimensions into a relational table. But because we are talking all about relational here, we don't have that functionality with the outline load utility. So we will leverage the data export function, calculation function within Essbase to export data into relational tables too. The process we are indicating here is very similar to the process we used to upload. So essentially the three define sections. So the first one points to the global configuration parameters. The second one points to your library, where you define the functions, where you create the wrapper to encapsulate the command line utility, and also the statements per se. So each statement is associated with a property file, and the property file makes a reference to a target, in this case, to a table that is a target for our data or metadata. Regarding the parameters, very similar to what we did in the parameters we used to upload data. So essentially three different set of parameters when we require. So this is just for reference only, so you don't have to worry about it or be scared about this one. So again, what kind of components we need to define here? First of all, we need to define the target. So again, if you export your dimension manually to a text file, you will find all the potential data elements that you want to export into your table. So you will find what you need, and then you create the target table accordingly. You can have a parent-child relationship, alias, data storage, aggregations, UDAs, you can include attributes, everything that you want from your dimension, that you will want to extract from planning from your dimension, you can have it there. Then we have the mapping file, is the JDBC parameters to connect to the target. And here, as we can see, there is a simple SQL query. So the first parameter indicates which dimension we want to export. And then with a single query, we are able to retrieve the data from the planning element side and map that to and insert that into each of the fields of the table, the target table we define. So this is really nice because you have control, as I mentioned before, on everything. There are no black boxes here like the load, space load rule that we define that, but we don't know what is actually behind the scenes, and sometimes we don't know how it behaves depending on some particular conditions. Here, that is not the case. You have an explicit SQL query and a standard one that you have control on. You can have, for example, the where clause, so you can filter even from the source what you want to extract. If you want to use a filter by UDA, for example, or by attribute or by label, you can do that, and you can have a nice extract of your metadata and clean already. We mentioned that we don't have the option to export data into relational tables using the outline load utility. So here what we can do is we can leverage the data export calculation function in Essbase. So we can export numeric data into a relational table like this one, where we have all the dimensions defined, and then we have the data field. And of course, if we do that in this way, if we had initially text data that we may tag as the text data in planning, we will have a number instead of the text as we are expecting, because we are extracting data from Essbase. So what we can do is we already know that all the text data resides in the HSP text cell value table inside the Hyperion Planning repository. So we can make a reference to this table and then select all the members that are tagged as text in planning, and then join those with this table, and they will have a nice result, a new table where we have the numeric data combined with text data. We are using this functionality a lot because we load some comments, for example, for any particular data set. And also we allow the users through web forms to enter comments when they make changes, for example, to forecasts, to budget, when they create transfers. They enter comments also. And we need those comments because some cases are really important. We need those comments out there for reporting purposes. So we can use this functionality and extract those comments combined with the numeric data. And it is, as I mentioned before, it's really helpful and it works nicely and without any issues. All right, now we can do, and it's a way that we did for the align load, creating the wrapper and create functions. In this case, we can do the same. So we can create functions, define tasks, and create functions to wrap and encapsulate the align load utility to export data. So first, we define which parameters we need. In order to do that, we define the function. In this case, again, we are just using as a parameter for this function the planning application and the property files. We predefine the parameters we need, and we don't have to worry about that because the parameters are entered, go directly here, and the other parameters are coming from the global configuration file. So we have this function, it's a wrapper, and with this function, we'll be able to export dimensions to tables. All right, so now what we completed so far. We have defined sources, targets, a mapping between the source and the target with planning, and also we define the wrapper functions that make use of those elements. So now let's see how we can put everything together. We have the sources defined, the targets defined. We have the property files associated with each particular data load or data export. We also have a configuration file that have the parameters that are used all across the system. And we have a nice import and export library functions that are encapsulating the command line utility. So now that we need to create these the scripts, the actual scripts to automate the process to import or load data or export metadata and data. Let's see how this script looks like. So actually, this is as simple as this one. So this is the full process automation script. So in this script, we want, for example, to work with this particular application, the budget application. Okay, we define a global variable. Then we want to update a smart list. So we make a reference to this library. We use this function that we defined before. We enter the parameter. You remember that we have three parameters actually. We have the planning application and the property files. And then we are saying that we don't want to refresh yet. So who really defines what is the behavior of this command is the property files. But if you are using the proper name convention in the property files, you will notice that immediately that we are doing here is we are updating the SL element smart list. Also, we want to update attributes. We use the same function with the same parameter and different property files. And again, if we use a proper naming convention, we will notice immediately that we are actually uploading an attribute dimension. For all the dimensions, we can do the same. Use the same function, and then the property files identifying what dimension we are loading to. And now, because we are done with the metadata, we can refresh. So now we are refreshing the outline. And we are ready now to upload data. So we point to the library, we use the load data from table that we defined already with the proper parameters, and then we upload, in this case, actuals. So this is self-explanatory. You don't have to spend time putting too much documentation here unless you want to, because it's kind of explicit. Whenever you open your script, you will notice exactly what the script is doing, and you can change the behavior. You can comment out that you don't need to update the dimension anymore, or that you want to change something, you go and update these particular property files if you want to upload an additional field or suppress one. Again, within the same script, you can have export statements. So you can use the export dimension table that we already defined, the point to the proper the mapping of the property files mapping to the target. And besides that, in our case, we have some other libraries. We don't only have the planning library with the encapsulating the outline load utility. We have libraries where we encapsulate SQL statements. We have libraries where we encapsulate MaxL statements, but we encapsulate some other functionality like LCM in planning and security and in shared services. So in the same script, using the same kind of naming convention for the functions, we have everything. So in a single script, we can have a really complex process, but the good part is that it is really easy to understand, easy to follow, easy to maintain, and easy to modify. Um, Again, this is the way that we mentioned before, how we wanted our process to be organized. The first one is the global parameters. The global parameter is just a single call to a function or a script that set all the parameters in the global configuration file as a variable for the environment. Here we are pointing to the library because we are using here the Windows shell scripting. This is kind of tricky to use to call to a library, but if you are using another scripting language more elaborated like Python, a call to a function within a library is kind of straightforward. So for us here, this is how the library looks like the planning library, where we have all the functions that are encapsulated in the command line utility. So in this case, that we do is the first thing that we do in the library is a call. So like here we are calling something, passing all of these parameters. So when it comes here, it makes a second call and it points to the actual tag for the function. And then it uses the rest of the parameters, execute the code, then exits here locally. And then from this point goes to the end of the library and finish the process. So we return when it was called. It's kind of tricky, but you don't have to worry about if you are using another scripting language that allows you to actually include libraries and make call to those libraries. All right, so right now we saw how we define sources, targets, how we define mappings, and how we encapsulate the outline load utility to create a nice and really self-explanatory script that is easy to maintain and easy to create. So now let's say some suggestions for you in order to succeed with your deployment or your integrations using the outline load utility. Essentially, as we saw here, define naming conventions. So it's really important that if you have, you define your naming conventions to name metadata tables, or data tables, and you name your scripts, and you name the libraries, and the most important part, if you name in some, you follow some particular naming convention for your property files, it will help you a lot to maintain your scripts. Also, define your process, what kind of processes you have. You can, according to those processes, you define your configuration files for those processes. You should have in place your function libraries, your property files also, and the process scripts. And also, the important part here that is essentially the objective of this presentation is define your libraries, define your function libraries. So don't use direct calls to the outline load utility in your main process script with a huge number of parameters that if something changes, you have to go through all these calls and change that. So, and also it makes really difficult to understand. So your scripts will be cumbersome, clunky, and actually there is a lot of information there that at the first glance, it will look really, the lack of organization in your script. So if a good practice is create the libraries, that's the whole point of this conversation. Another part is develop templates. So you can, once you have the libraries, you have everything in place, you can create templates to import, export, transfer data. And you can also create templates for the property files. So whenever you want to create a new property file, you already have the template there. You can improve your functionality by including some other libraries like MaxL, security, as I mentioned before, LCM, you can include SQL statements, operating system, like, remove files, copy files, do a lot of things. We have that, and again, we have everything in a single script, and it works perfectly nice. So one last word is the command line utility is reliable. It's really easy to set up and maintain, and it doesn't require any additional software. And as we saw here, we can simplify the integrations of this process by creating functions, essentially a wrapper, by having objects that map source to target, that is essentially property files, and then we can integrate together in a single script. So this is what the information I wanted to convey. This is the part that I wanted to let you know. Essentially, that if you are thinking about using the outline load utility, I think that is a great option for you to have that. I want to thank you for sticking with me until this point, and thank you for attending this presentation. Please let me know if you have any questions.
Very good. Thank you so much. We actually got a comment that said, lots of value. Thank you for your diligence and care for detail in this presentation. So very nice job, Mauro.
Okay, thank you very much, Robin.
Anybody have any questions? If so, type them in the Q&A box at the bottom of your screen. Okay, so the question, are these slides available later? We will actually be having recording sessions posted at epm.bi/solutions within 1 to 2 weeks following the conference. So everything will be available at epm.bi/solutions. And then there was a request to share your email address, Mauro. I don't know if you're comfortable doing that.
I think that I will ask if you don't mind, Robin, if somebody wants to send you an email, you can convey that information to me. I can respond.
That sounds good. That sounds good.
Yeah.
Yep. So if you're interested in contacting Mauro directly, please contact me at rklaterbaugh@interrel.com. And then there's another question that came in that says, does the planning outline utility functionality change between 11.1.2.4 and 11.2?
Well, I personally haven't used that and haven't tested the functionality in the 11.2 version. However, checking the documentation doesn't change too much. It doesn't mean that the functionality hasn't changed. I truly won't expect that, but if it changes that I have seen from 11.1.2.1 through 11.1.2.4, it didn't change too much, actually. So I wouldn't expect probably to change that. I haven't seen any reference in the documentation from anybody that this functionality has changed, but certainly it's something like if you have already a deployment in 11.2, I will encourage you to go there and test right away to see if everything is still available, but I expect to be there still.
Okay, great, good. And then another question came in, is this option the same as using Classic in 11.2 instead of EPMA?
Yeah, that's exactly the same one. Something that I probably forgot to mention is that, of course, all of this is related to classic planning applications. So the first thing that we did when we migrate from EPMA to release EPMA out, and we went to use the outline load utility, we move all the applications to be classic applications. So I would expect the same, of course, to be the classic one in 11.2.
Okay, great, good. And then finally, can you review how the Essbase load rules and data export fit into the automation? Are there scripts that trigger that component?
Well, again, in the similar way that we use the wrapper to encapsulate the call to outline load utility, you can make a call to MaxL internally, and then you can pass a string that is your actual MaxL command as a parameter, and then you create a function for that. So and you can define those strings. And each function you want to, like for example, if you want to execute a calculation, then you pass the calculation itself, the calculation name as a parameter, and internally you create a command and pass that command as a parameter for the MaxL call. So in that way, you create very similar way, actually. It's very simple. It's very similar that we have with the outline load utility, and very similar to SQL statements, for example. You can make a call to SQL plus and then pass the actual SQL statement as a parameter. So you can encapsulate everything in very similar way.
Okay, great. Very good. Any other questions? This is a very informative and detailed presentation, so thank you so much.
Oh, no, thank you very much, Robin, for having me, and I appreciate everybody was here, and thank you.
Yes, thank you.